Geometry lesson, reasoning and proof. Okay guys, we have a warm-up here. It's a spiral review of stuff that we should be somewhat familiar with. Some of them may be kind of new, so do your best. Just be mindful of the sentences, the words that we use. The word bisect means what, guys? If you don't know what it is, please look up. And what does it mean to be acute? And things like that. Okay, pause the video. Okay guys, so I'm assuming you're done. So let's move on to this. Here are the answers, guys. This is the key. I drew in the lines over here for the point of reflection here and here for x and y. And I just literally counted the number to reflect this way. And seeing that that's a gap of two values, the y value that is, you go down 2 from 1, which gives you -1. And that's how I got the values, and I just plugged in x and y into this to get this answer. And here's the transformation, 6, 3. And the key thing over here was that we knew that because DF bisects CDE, like this and this is the same. So this right here and that was the same. And it's also said DG, this one right here, bisects this angle. So these two are the same, right? So all I did was call this x and x. Because this and this is the same, that must be 2x. Now, if CDG, right there, is 51 degrees, that is 2x plus x, which is 3x. So I found the x value, which is 17. And the question is asking you CDE. CDE, that's made up of 4 x's. So 4 times 17 is 68. Acute angle is between 0 and 90, so set this equal to between 0 and 90 and solve for it. And you should get x is between 7.5 and 22.5. And naming the ray. The requirement for naming the ray is that you have to write down the endpoint A for both of these, right? And after that, it really doesn't matter which point that you use, but it just has to be on that ray. So you had a choice between B and a C. Hence, there are two different ways of naming that ray. So it's ray AB and ray AC. Also, I've said previously, note the way we annotate them. The notation is kind of like drawing a mini graph, right? Clearly A is the endpoint and B is somewhere in the middle of this ray. Okay. What I should have done is that it should be an arrow like this, not a half arrow. Okay. All right, guys. So let's start with going over the definitions. So the definition, conjecture, is a statement that is believed to be true, right? And so quick way to think about that is that conjecture is a guess, but not guess like some random guess, right? But it has to be an educated guess. When I said educated guess, you have to have some evidence behind it. It can't be an opinion. Conjecture is a guess, but it has to be an educated guess that has where you have a reason to believe that is true. You have reason to believe that it is true, right? And that particular conjecture is that you could either have inductive or deductive reason to that, right? To prove that conjecture may be true, okay? If you could prove to be true, it's called a theorem, right? So inductive reasoning is the process of reasoning that rule that statement is true because the specific cases are true. In other words, inductive reasoning is that you've seen many specific cases and then you come to a general rule. For example, you may see that, especially at NBA, that a lot of the players at NBA are well over 6 feet tall, if not near 7 feet tall, right? So you see that again and again and again and again, and you might come to a general conclusion. The keyword is general conclusion, general rule, that NBA players are tall. That is mostly true. There have been cases where we had short NBA players. I could think of two right off the bat, but we won't get into that. I believe one was like 5'7". The other one person is either 5'3" or 5'5". I'm not quite sure. Well, anyways, let's go into the second one. The deductive reasoning is a process of using logic to draw a conclusion. In that particular case, the direction of the reasoning has switched. It's swapped from the inductive reasoning. Here, we apply the general rule to specific cases, right? So if you know a general rule, then you say when something arises, you apply that rule to those instances, right? All right. The theorem is a statement that you can prove is true using series of logical steps, definitions, axioms, other theorems, and stuff like that. Okay. Counterexample is an example that shows that conjecture to be a false, right? So when we ask you to prove something is false, you only have to show only one example. So one counterexample, right? And the conditional statement it's basically an if and then statement. So it's a statement that can be written in the form of if P then Q, where P is the hypotenuse and Q is the conclusion, right? All right, guys, so here are some properties that we have done in the past. We'll just quickly go over them, right? Addition property of equality. When you say all that, it means there has to be an equation, right? So, for example, if you have A and B, you could add C to the both sides of the equation. You see that right there, guys? Right. And the subtraction property is when you have could subtract to both sides of the equation. So what that means is that if A and B are equal to each other, for example, like A is equal to B, if you subtract C from both sides, the result is still the same. So basically, this right here is the if. That was the action that was done onto them. We subtracted them. Then this is true, right? We've been doing that since you were as long as you've been learning algebra, right? So we just are giving name to them. The multiplication rule is that you can multiply to both sides of the equation. And the division property is property of equality is if you divide by the same number, the both sides should be equal to each other as long as the denominator is not equal to 0. As long as you're not dividing by anything other than 0, you should be fine. Okay? Reflexive property basically says that anything is equal to itself. A is equal to itself. It seems kind of obvious, but we have to say that. In fact, we've been using it. So what happened was, if A is equal to B and negative C is equal to negative C, that was actually a reflexive property. And what we did is we actually added the two equations, the equation on the top and the equation on the bottom. So when you do that on the left-hand side, it yielded A minus C. On the right-hand side, it yielded B minus C. And that relationship, that equivalence relations, must remain the same. It still remains true, that is. Okay. So transitive property, I like to think of that as almost like a chain rule, right? If you look at the first two, it says A is equal to B, and the B is equal to C. So trans is that going across, or trans across, from the first to the last in the series of equations, the relations that is. If A is equal to B and B equal to C, then going all the way across, A must be equal to C. Do you see that argument right there, guys? That's a transitive property. And it works not just with equations, but congruence statements and also similarity statements. We'll talk more about that later. Okay. And the subtraction property of equality, right? I'm sorry. Substitution property of equality. If A and B are equal to each other, then you can replace B with A in any expression. So for example, if A is equal to B, right? And we know that, I don't know, 2B is equal to k squared. Then, by substitution property, we could say 2a is equal to k squared. Because a and b are equal to each other, wherever the b appears, we could substitute it with the exact value of a. So if this statement was true, then this also is true by a substitution property. Okay, so this is a little bit of algebra review. So let's take a look at this right here, guys. So we start with the first sentence right here, guys. Right? And now what do? So this is the given statement, given. And what do we do to both sides? We added 4 to both sides, right? So this is the addition, right? Property, prop, of equal sign. You could give shorthands if you like. Prop, sorry. And the next one, we divided both sides of the equation by 3. We would call that division property, div dot prop dot of equal property. And then we swapped the order in which it was written. I'm sorry, guys. I guess I didn't talk about this. I just realized if A is equal to B, B is equal to A. You could change the order in which you write them. So that's exactly what we did. So this is called a symmetric property. Symmetric. I like to actually write that one out for some odd reason. Property of equal. Okay. I'm just going to leave this as an exercise for you guys. So if you have a question about that, we could talk about it. So this was given here. And then how many steps do you need? You may not need to fill out all the steps over here, guys. Okay. When you're done, you're done. Example 2. It says write each statement as a conditional statement. So this is a declarative sentence. And we need to write this as a conditional statement. So we have to say if something, then, then something else. That means the same thing, right? So how do we do that? All zebras belong to the genus Equus. Okay, so we have to have a sentence that separates those two together. The idea, all zebras should go here, belongs to, that should come into the second one, right? How do we do that? So you may have to introduce new words in here, guys. So if an animal is a zebra, then the animal belongs to, let me change it up a little bit, guys, to create a little more space. There you go. Let's move it up to the left. Belongs to the genus Equus. Okay, there you go. All right. So that's how you do it. So you have to introduce new words. So do me a huge favor. Take a minute to try your turn. Majority vote is required to be voted to be the captain of a volleyball team. There are different variations. Everybody sort of writes a little bit differently. So don't worry if it doesn't look exactly like mine. Okay, guys, go ahead. All right. So the way I answer them, guys, is if a person gets the required majority vote, then he/she is voted to be the captain of a volleyball team. Okay, that was one possible way. If yours is pretty similar, it should be good enough. But if you're not sure about it, we could talk about it in the classroom. All right, guys, we're going to learn about linear pair theorem. What it says is that if two angles form a linear pair, then they're supplementary. So what that literally means is that if two angles form a linear pair, so there are a couple of things that needs to happen. One, they have to have a shared side, right? They have to have a shared side. It can't be overlapping, it has to be a shared side. And then shared side not shared forms a line. So all that was implied in that sentence. And if that happens, then those two angles are supplementary. But what does it mean to be supplementary, guys? The angles, the measure of the 3 plus the measure of the 4 has to equal to 180 degrees. Okay? So this would be more of an example. All right, let's do an example, guys. So use a postulate or theorem to find the value of x in each figure, and please state the postulate or the theorem. All right. In this particular case, we notice that this length is rs and we have st. They're given two different expressions, but we're also given the separate expression for the entire length st. Do you remember what that is, guys? Yeah, that's right. It's a segment addition postulate. What that literally means is that two segments that make a bigger segment is equal in length. So rs is x plus 2, st is 3x minus 8. Let me zoom that in a little bit so it's easier for you to see. Is equal to rt, which is 5x minus 12. On the left hand side, that gives you 4x minus 6. Copy the right hand side. So we're going to subtract 4x from both sides. When we do that, that yields x. And we're going to add 12 to both sides. When you add 12 to this, what do I get? 6, right? And here it becomes a 0. So we don't have to write about that. So x must be 6. So we might say, therefore, x has to be 6. And get in the habit of showing off your answers to show how proud you are of your achievement, right? We got RST right here. RST is 15x minus 10, but two angles that make that up is what? We have two different expressions for that. So it's very similar to what we just did, except instead of being a segment, it's an angle. So it's called angle addition postulate. So what we have here is that measure of the angle RSP plus the measure of the angle PST is equal to the measure of the angle, this big one right here, guys, right? Is equal to RST. But RST is 15x minus 10. And PST is given to us as 5x plus 10. And RSP is x plus 25. That gives you 6x plus 35 is 15x minus 10. That is because x plus 5x is 6x. And 25 plus 10 is 35. Subtracting 6x from both sides of the equation, the left-hand side disappears, leaving only with 35. 15 minus 6 is 9x. Add 10 to both sides, yields 45. Dividing both sides by 9. 9 times what gives you 45? Nice. X is 5. Therefore, x is 5. There you go. Okay, guys. So now it is your turn to do the your turn. Pause the video. All right, guys. Here's the answer. If you have a question about it, we'll talk about it in class. But there it is. You can pause the video and copy it over, okay? All right, so we need to talk about some postulates about different points and whatnot, right? And we're almost done, okay? We're learning a bunch of names right now. Through any 2 points, there's exactly one line. That is it. We're done. In some books, they may phrase it slightly differently, right? They may say something like, oh, I don't know. Let me just zoom in a little bit. 2 points. I think the wording that most books use is either determined or form a line. That implies one line, right? Good. So through any 3 keyword is non-collinear, right? So they cannot be on the same line. As long as they are not on the same line, there's exactly one plane containing them. Similarly, some books will say 3 points determine or form a plane. So that's an option, guys. Okay. If 2 points lie on a plane, then the line containing those points, lies in the plane. What that means is the following. If these 2 points are on this plane, then everything on that line that contains those 2 points are also on that plane. You know, sometimes these things seem almost, while we're talking about this, it seems so obvious to some of us, right? It comes in handy. It will be used as a starting point to build something bigger. Hence, it's a postulate. These are given truths that we'll be using as a building block. It's like a Lego block, right? Putting all these blocks in a slightly different way, you create a new shape. And that new shape, mathematically, speaking metaphorically, is new theorem. And new combining theorems in a different way gives you another theorem to find bigger truth and larger truth and so on and so forth. Okay? All right. So if 2 planes intersect, then they intersect in exactly 1 point. Right there. And also, if planes intersect, then they intersect in exactly 1 line. Right here. Okay? All right, guys. Let's move on to the next page. And we have one example, and let's go from there. In this particular case, it's asking you the line of intersection of 2 planes. So what I see is that we have plane F. See that right there, guys? Plane F. And there's another plane right here. And that's plane N. What's intersecting that? It's this one right here, guys. So I'm going to call that line BD. I suppose you could call it CD or BC, but I tried to use the one that was in the edges right there. Okay. All right. All right. It's asking you for 3 coplanar points, meaning 3 points that are on the same plane. So in case of plane F, what are the points you see? On this plane, I see B, D, N, E, and C. So if you said any 3 of the 4, you'd be correct. If you decide to go with, let's say, I don't know, plane N, I see. So we have B, D, and C is on this plane. On top of that, we have A. So that would be A, B, C, N, D. All right? So if you chose any 3 of the 4, you'd be considered correct. And it's asking you to find 3 collinear points. And in this particular case, there's only one choice of this line. That will be points B, that meant to be a period, B, C, and D is on line BD. So instead of writing line BD this way, you can also write it as a line BD. Okay. Now, obviously, there are infinite number of lines over here, but because they were not named, we can't just make up names, right? So that's the only answer possible. All right, guys. This is the last your turn of the lesson. Here's a figure. Pause the video and do your best. All right, guys. Here's the answer. All right, guys. So that ends today's lesson, and we'll talk about this if you have any questions in class, and we'll be going over homeworks and stuff like that. All right, guys. I will see you in class. Bye bye.